Hi everyone, welcome to Code and Chill. We are continuing our exploration, which started with this question, removing stars from a string. We started with the brute force solution. So just a quick recap. And as expected, looking at the time constraint here, the brute force solution created a time limit exceeded issue. And then we saw, okay, so what is the time taken by this, right? If we want to know, we have to reduce the time or change our approach. First, we need to know what is wrong or what is causing it to have extra time, right? So that's where in our previous video, we took a very basic approach to understand time complexity and saw that this takes O of n square time or quadratic big O time. And clearly because of that, 10 to the power 5 is the string length. And if, let's say, it takes 10 to the power 10 time because of this time complexity, and let's say, okay, let's ask ChatGPT in LeetCode. Okay, this is again the continuation of our previous questions, right? So I just kept the same window. Now in LeetCode, if the complexity of let's say complexity of code is big O of n squared, then how much time does LeetCode, I don't know, server take to run this in microseconds maybe? Okay. So if it is, say, 10 to the power 8 operation, right, it is saying it will take 100 seconds, it will time out, right? So for us, it was 10 to the power 10, right, in the worst case. And clearly, it will be 10,000, right? 10,000 seconds in that scenario, which will time out. So awesome. So now we know the time, right? This is what we looked into. And now we know that because of all these reasons, this is not going to work. Awesome. But we also came to know some very important things in this solution as to what is causing this time delay. One was this string slice operation and concatenation, which took O of n time, which was inside a while loop, which took O of n time. And because of that, O of n into O of n, so basically O of n square time was the time complexity. So is there a way to reduce this, right? Then if can we make this, so let's take step by step. If this is O of n time, can we make it just O of 1, which is in our previous basic terminology, 1 unit of time? Can we make that a possibility? Is there a different way of looking at it? Okay. Sometimes algorithms helps us, sometimes data structures help us to reduce the time complexity. But to do that, first we need to identify what is causing the issue. So there is a string here, right? And the string, substring, and concatenation is happening. Can we do something else? So if we go back to this input, instead of every time when we have to remove this, we delete this, add both the remaining strings, delete this, add both the remaining strings. What else can we do? Can we avoid the substring operation? That is a good question. What do we want to do? Let's see. Let's just write it down. right? It might not be really intuitive. So let's just write it down. I'm writing in such a way that it will take us towards a specific data structure. Okay, that is one hint. Now, according to this, right, according to our brute force approach, we will start from the leftmost letter. Okay, so we'll start from E. Okay. If we encounter a star, we'll do something, but now we didn't encounter. So we will go to the next letter. We will go to the next letter. I'll just put one line to separate the letters. Okay, it doesn't mean anything else. Then we will go to A. Then we will go to S. Then we will go to E. And then we encountered a star. So if we encounter a star, we have to delete the star and the letter just before it. So since we encountered a star, we will delete the letter before it. Okay. We saw the string till here. Now we saw another star. Now if we encounter another star, we have to delete the letter just before it. Then we encountered another star. So we have to delete the star as well as the letter before it. We encountered another star. So we have to delete the star and the letter before it. We encountered one more star, and then we also delete the letter. If you closely observe, there is a specific data structure that was used when I'm showing the example. Now, it's possible you've never encountered this data structure, so you will not know what I'm speaking about, but let me just show it visually once again before jumping into the concept. Okay, so now we have L. It's not a star, so I'll just keep it. It's not a star. Keep it. Keep it. Now we encountered a star. At this point, we say we will delete the previous letter as well as the star. Then, okay, let's just go to the next part. And then we say we found a star, so we'll also delete the letter. Then we didn't have any stars, so we will go on adding it. Go on going to the next one. Then we found another star, so we'll remove something before it. And then we added the last letter. Now, if I put all of them back together, this is the final answer. Now you might tell, okay, you did something, but I don't know what the heck it was. I don't know any data structure that can relate to this, right? That's possible if you're looking at it for the first time. I'm not sure if there might be a better way of, coming to this solution, but don't fret. Let's look at stacks and come back to, the solution, and then this might make more sense. And then we will see how we remove the time or reduce the time complexity from O of n to O of 1. Okay, are you ready for that? Maybe you already know about stack and you know what I'm speaking about. Anyway, can you give me an example of, can you explain stack data structure, considering me to be someone who does not have any idea about data structures? Let's see how it explains. Yeah, this is usually what we come across. So, cool. It gave out some helpful stuff. But anyway, as usual, I first like to go to the example. Let me just move it a bit and see what stack represents. Thankfully, stack, this word comes from our day-to-day usage, right? Let's say we have a book 1, and then I'll just copy this, right? Copy, paste. So then we have another book on top of it. another book on top of it, one more book on top of it, and one more. So this, architecture is what you call a stack in our day-to-day life. Okay, this is very basic, right? Now, how do we translate it to a computer science data structure called as stack? Well, basically, we are told that the stack data structure, right? Stack data structure looks like this. That means when they store the value, right? When a value is being stored, maybe I can choose this, choose a different color. And, okay, this looks good. Add a line. The stack data structure also has values as though they are one on top of the other. What do we mean one on top of the other? Just like how we cannot get, access to this book without removing these books first, right? We have to remove this first, then we can remove this, then we can remove this, and so on. Similarly, if there are any values, let's say we are storing for ease, right? Let's just say we are storing some letters. Okay. Now, the only way we can get to A is by first removing these. So that's where there is an analogy. Okay, so the operation where we remove this is called as pop operation, and the operation through which we put one more letter into it is called one more value. Okay, if it is F, we call it as a push operation. So let's see. If you look at this, so there is a push operation, adding something to the top of the stack. And then there is a pop operation. There is a peek operation. When you say peek, that means you can just see the top of the stack. You just see, okay, the letter, okay, I'm sorry, the letter was F, right? Sorry for the bad drawing, I'll just change. So when you're peeking, you're not removing anything. You are just looking at the top value here and saying, hey, I saw that value was F. Think of somebody who is on a ladder, right, and trying to just take a look at what is over here. Right? They are on a ladder here, and they are just climbing up this huge data structure and just taking a peek at what is going on. Okay, they're just looking at this. And they are saying somebody who is outside what that letter is, right? So these are some of the operations. What else? Is empty is also something we see that's helpful because, well, we will know when it is helpful. That's also another operation. And what else? So unlike an array, now we know about arrays, or we have seen some array problems. We try to show the array in this manner. Here is this. I need one more line. Okay, let's say in an array, we have access to all the letters. How do we have access to that? So let's say we have A, B, C, D. And then I can know what is here. I don't need to remove something from behind or anything. So if somebody says array of 0, I directly can know that it is A. So you can imagine that there is a door and a key, all right, that can access each of these. Whereas here you can consider this as a wall and you have no access to it. Okay, as long as you remove the above one and then this wall opens up to see this one, and so on. That is a way you can visualize it. Right now, okay, we got some understanding of a, where is it? Stack. Just an analogy still, right? We have not implemented it as such. But how is this going to help in our problem, right? How is this going to help us with this time complexity or in this problem? If you closely look at what I was doing here, if we go back here and draw it, maybe closer to this, I'll just paste it here. What was going on? Just think, instead of a substring operation, right? We are going to you put these elements into a stack. So what are we going to do? Okay, now for the we can iterate over each of the letter in the string. So this is a string, right? We have a pointer, and can we add arrow here? Okay, so let's say the arrow is initially pointing to, oh, the arrow is here. Okay, just want to point it the other way around. Let's take the arrow and say, okay, so what we are seeing here is there is an arrow pointing to the first letter. That's what we can do in the string, right? We can iterate over each letter and find str of I, right? So we are at I equal to 0 right now. Okay, I equal to 0. Let's say we didn't find a star, so we put that letter into a stack. So push str of 0 to stack because it is not a star. Simple. So let me show that pictorially. So I have a stack and I put L inside it. Okay, now I take this entire thing and move, and I move it to, that is bad. Let's copy the entire thing and I will move it to the next one. I'll say I equal to 1. Now this is again a non-star. So I will push another, push is the word, okay, push another letter on top of it. Then I go into I see the next letter and the next letter. I hope you understand. I won't keep moving the arrow. We go to 2, we go to 3, and then we say, okay, we found non-star. Okay, we found another non-star and we put it to the stack. Now in the stack, can we see what is here? No, we just see the top of the stack, right? Just imagine that everything else is not available for you. You can just see the top. You can either pop it or peek. You can either peek or pop. So now I is equal to, let's say, I'll remove this extra stuff. Now let's say I is equal to, what is that? 4. So the arrow, okay, I didn't copy the entire thing. So the arrow is pointing to the star. Now this becomes interesting. We say, oh, we encountered a star. Let's remove the last letter or pop the last, basically it will be pop the element in the stack, right? That's what we're going to do. So for that, we first remove that. Done. Then we go to the next star. It's as good as deleting that star also, right? Now we go to the next star and then we delete this. Okay, I can just delete this. Now we come to 6. So C is again non-star. And then I add it. Similarly for O and D. Just go on adding it. So this will be C, this will be O, this will be D. Then we encountered a star, so we will remove this. Then we found E, so we are gonna, E is non-star, so we are gonna add. Then we are gonna get all of these out of the stack and we are going to return that as the answer. So let's quickly check with ChatGPT to do that. I'll just use the same instruction, but say use stack. So given a string s which has a star and non-star, consider we start from the leftmost. Go on adding the letters to stack as long as it is not a star. If a star is encountered, delete or pop the letter in the stack, and then after iterating over the entire string, assign the entire get the letters out of the stack into a string in the opposite order of the stack. Let's see if it understands, or we can update this. Okay. I'm not too sure whether it will understand what I said here. Basically, what I was saying is when we pop or go on popping, right? First we will get E, then we will get O, then C, then E, then L. And our answer will be actually the opposite order, which is L, E, C, O, E, right? So let's see what happens. So for each letter, if it is equal to star, it will pop it, else it will push it into the star, and then it will do a join. So if it does a join, I'm not sure. Let's see what it does. So if this is the input and it goes on doing this, so if it is A, let's just go and add it now, and we will know if it is the opposite direction, right? So I'll just submit it. I just want to make all these notes, keep it in the submissions, even though it will fail. Actually, I could do it in a different way anyway. Now I can just remove it all and put this. Just remove these and see if I run it, what will I get? It is interesting to note that this is how you initialize the stack in JavaScript. In Java, it is different, and similarly in other languages. So looks like the join operation is joining from the beginning. So let me ask it to explain. Can you explain the join operation, how it works basically? So in JavaScript, it takes this, it is initializing it, it's holding it as an array and a stack. You see? So that's a bit of a JavaScript stuff going on there. We will ask, how would you write this solution in Java? There you will see a proper stack definition, right? So if you see there is a new stack, and then you start push and pop, you see here the result is appended, and then a toString operation happens. Cool. So now let's go back. You see this is working, and now here if we look at the time complexity quickly, this is a O of 1 operation, or using our previous explanation, it is just unit time, right? And this is unit time. This entire thing will run for the length of the string, so it becomes a O of n operation from a O of n square operation. So that looks very interesting. Now we'll just copy this, add a, can we add this as a use case? Use test case. All right. So now let's run it and see if it is working. It is. That's wonderful. So now we can go ahead and submit and see how that goes. Awesome. So we see the runtime. The runtime is slightly low still. I think it's could be something to do with the join operation too. We can analyze complexity. Oh, I need to upgrade. Sorry about that. We can also ask ChatGPT. It's quite interesting. Well, I think we learned a few things today. We learned some, let's say, kind of a basic overview of stack, saw the pictorial representation of stack, and solved a problem using that. Not bad, right? We reduced the O of n square time complexity to O of n time complexity, which was awesome. This is just the beginning of stacks. We will solve some more wonderful problems using stack, and I hope it starts growing on you. Hope you had some fun, and thank you for joining me. See you in the next episode.